Cardano blockchain is facing a major network technical upgrade, the vasil hard fork. This is the most complicated upgrade in its history, as it includes changes in both Cardano programming language and the Cardano consensus protocol. The vasil upgrade is expected to bring a host of changes in terms of transaction fees, scalability of the decentralized applications, as well as in the speed of transactions. The new development will bring about significant network enhancements that will shrink transaction sizes, thereby increasing network throughput, which will result in cutting transaction fees. Vasil will allow developers to store and reference information without having to use output. This will optimize transaction throughput and increase the concurrency of the blockchain. It will also significantly increase the speed of the transactions. It is expected that the upgrade will resolve the current concurrency problem that has seriously hindered the capacity of Cardano's decentralized applications to scale. The vasil upgrade is part of the Basho phase of the Cardano roadmap, which focuses on scaling and network and ledger optimization. Vasil will be deployed at the protocol level using Cardano's hard fork combinator, innovative technology which enacts seamless protocol transitions and ledger upgrades, minimizing disruption for end users. The upgrade will implement widely anticipated features such as diffusion pipelining and upgrades to Plutus, Cardano's core smart contract language. Many of the improvements have been developed with the support of the wider development community and stem from Cardano improvement proposals. So let's take a closer look at the main vasil changes. Diffusion pipelining process will improve block propagation times, thus enabling higher throughput. In essence, it streamlines the process of sharing information about newly created blocks among network participants by ensuring that blocks can be shared in the network well within 5 seconds after their creation. Diffusion pipelining propagates blocks before their full validation, thus overlapping the time spent on diffusion with the time needed on validation. Pipelining also ensures that the block header referencing the hash of a previous block is propagated correctly. The body of the block is retained within the metadata included in the next block, which is essential for DDoS attack resistance, even without full block confirmation. Vasil will further improve the already powerful Plutus platform. Previous datums were carried in transaction outputs. They stored and provided access to information on the blockchain. However, to access information in this datum, one had to spend the output that the datum was attached to. This required the recreation of a spent output. The addition of reference inputs now allows developers to look at the datum without extra steps. This facilitates access to information stored on the blockchain without the need for spending and recreating UTXOs. Transaction datums were previously attached to outputs as hashes. With the implementation of inline datums, developers can now create scripts and attach datums directly to outputs instead of using their hashes. A user can see the actual datum rather than supply it to match the given hash. In Alonzo, when spending an output locked within a Plutus script, one had to include the script in the spending transaction. This increased the size of the script, also causing certain delays in its processing. The reference SIPs upgrade allows developers to reference a script without including it in each transaction. This significantly reduces transaction size, improves throughput, and reduces script execution costs, since the script only needs to be paid for once. The vasil upgrade will also include Cardano cryptographic primitives improvements, enabling greater interoperability options for other blockchains, a tuned Plutus interpreter, and a new cost model, which are all parts of Plutus v2 scripts. Due to performance improvements in the Plutus evaluator, both Plutus v1 and Plutus v2 scripts have lower cost model parameters than before, resulting in 20 to 30% improvements in script resource usage. The updated cost model parameters extend the set of built-in functions by adding 3 new built-ins. The latter built-ins support elliptic curve standards, which provides better interoperability between Cardano and other blockchains such as Bitcoin or Ethereum. A serialized data function reduces the overall memory and CPU costs, allowing for more optimized and generic ways of data serialization. Following the vasil upgrade, developers will be able to see redeemers for all inputs, rather than just the one being passed to the currently executing script. Script collateral adjustment, SIP40, is another adjustment that improves transaction validation. Previously, the collateral amount was set to 150% of the transaction fee, and no change was provided to the collateral UTXO. This meant that if a script failed Phase 2 validation, a DApp user would lose all the funds stored in the UTXO chosen for the collateral. After vasil, DApp developers will have the possibility to specify a change address for the script collateral. If the script fails Phase 2 validation, only the collateral amount will be taken, and the remaining funds will be sent to the change address. Finally, Vasil optimizes Ouroboros' verifiable random function process. Before Vasil, block validation required 2 VRF functions in every network hop. Vasil drops one of these functions, resulting in faster block validation and network syncing times overall. The Vasil upgrade represents a step change in the capability of Cardano. Diffusion pipelining will allow for greater network throughput, while the new Plutus enhancements will open up new developer use cases and offer significantly improved user experiences. Due to this immense upgrade to the Cardano blockchain, Bonds.org will be entering the ecosystem with its own lending protocol. Subscribe to our channel and follow us on Twitter.